Here we have two questions, A and B. We'll discuss one by one. The first question is differentiate between electrical resistance and resistivity of a conductor. So we'll discuss about the difference between these two. See, here we have different properties and there are difference, electrical resistance and resistivity rho. So what is the electrical resistance? Which is nothing but opposition offered by a conductor to the flow of current. That is electrical resistance. Resistivity is nothing but a material property that quantifies how strongly a material opposes the current flow. So there is a difference. This is opposition offered by a conductor to the flow of current, whereas resistivity is offered by the material opposes the current flow. Now what is the formula for electrical resistance? This is rho into L by A, and from this we can derive resistivity rho equal to R into A by L. Now what is the unit of electrical resistance? The unit is ohm and resistivity is ohm meters. Now this electrical resistance depends on the material, length and cross-sectional area of the conductor, whereas the resistivity depends on the material property and independent of the conductor's dimensions. Now the last property is changes with dimension, if we see, varies with the length and cross-sectional area of the conductor, but here there is no changes, does not change with the size or shape of the material. So these are the difference between electrical resistance R and resistivity rho. Now let us discuss question B. Here the question is two metallic rods, each of length L, area of cross A1 and A2, having resistivities ρ1 and ρ2 are connected in parallel across a DC battery, and they are asking us to get the expression for the effective resistivity of this combination. Here we are saying the rods are connected in parallel across DC battery. So let us calculate the resistance of each rod, R1 which is equal to ρ1 L by A1 and R2 which is equal to ρ2 L by A2. So for resistance in parallel, the formula for the total or effective resistance can be written as R effective 1 by R effective, which is equal to 1 by R1 plus 1 by R2. So from this we can write along with the cross section A1 and A2. So 1 by R effective, which is equal to A1 by ρ1 L plus A2 by ρ2 L. So we can write 1 by L into A1 by ρ1 plus A2 by ρ2. So this is the effective resistance, R effective. We can write R effective, which is equal to L by A1 by ρ1 plus A2 by ρ2. Since the effective resistance of the parallel combination is related to the effective resistivity, we can write rho effective divided by A effective, which is equal to R effective. So we can write this equal to 1 divided by ρ1 A2 plus ρ2 A1 divided by ρ1 into ρ2. So from this we can write P effective, which is equal to ρ1 ρ2 into A1 plus A2 divided by ρ1 A2 plus ρ2 A1. So this is the final expression for the effective resistivity.